Hi, everybody. My name is Nick Tostenrud. I'm a senior manager of product management for Amazon Fraud Detector. Today, we're going to give you an introduction to Amazon Fraud Detector and talk about how machine learning can power your fraud system to detect more fraud. At Amazon and AWS, we've been fighting fraudsters for over 2 decades. Over that time, we've seen a wide variety of fraud, from payment fraud, uh, compromised payment instruments using stolen credit cards, different types of fraud related to prepaid cards. We also see quite a bit of account takeover attempts, both the traditional username and password compromises, as well as API key compromises. And then there's an endless list of abuse that we've seen across different things such as free tier misuse or premium phone number abuse. And as we've talked to AWS customers over the years, we found that they're facing many of the similar attacks as we do at Amazon and AWS. Fraud detection is difficult for a number of reasons, as evidenced by the billions of dollars lost each year to online fraud. As we spoke to more and more customers about how AWS could help them improve their fraud defenses, we found that many customers were facing the similar challenges that we have faced at Amazon and AWS. For example, fraudsters are constantly changing their tactics and implementing rules to detect these fraudsters uh, oftentimes is not efficient enough, and it leads to having to hire more humans to review transactions or events individually. And then finally, over the years, fraud detection logic gets baked into different parts of your systems, and so the fraud teams that are responsible for reacting quickly to changing tactics don't have full control over that detection logic, and they're often dependent on other teams. Uh, so this battle with fraudsters never really ends, and so companies such as AWS constantly invest in new protections. And one of the protections that we found works the best to protect against fraudsters is machine learning. So first, I want to talk about business rules real quick compared to machine learning, as many customers that we talk to are using business rules to detect fraud today. Business rules look for specific conditions or behaviors. They're very easy to explain and validate, which is great. Uh, for example, a new account registration rule could look something like this: an IP address location from a certain country and a customer address from a different country, and then the customer phone location is then from a third country. Because those three attributes don't sync with each other, you would want to investigate. So it's very clean cut, easy to explain, but they're very rigid as well. And it's hard to scale that when you're in an environment where fraudsters are changing their tactics constantly. Machine learning models, on the other hand, learn more general patterns by looking at lots and lots of historical examples. And so when a fraudster makes a small tweak to, say, the pattern in an email address, the model can still pick that up as suspicious, whereas a rule might not be coded to detect that change in email address. So for those reasons, ML models can be much less brittle than rules and help you scale your fraud system. Supervised machine learning is particularly effective at separating your legitimate events from fraudulent ones. Supervised machine learning takes in historical data samples as inputs, for example, past registration events, and their associated attributes, such as email addresses used to register or the IP address at the time of registration. Also takes in associated labels for those past events. The labels represent what you want to categorize or classify. In the context of fraud prevention, this is often fraud or legitimate, or a particular type of fraud versus legitimate. And you take that data set along with the associated labels, and you run the data set through an algorithm to produce the trained machine learning model. So I'll quickly walk through the steps at a high level of what happens when you train the machine learning model. First, you start out with your data set. In this example, the blue squares represent fraudulent events. Orange circles represent legitimate events. So first, we're going to split the data into a training set and a testing set. We're going to train the model to identify the space where orange usually is. And notice that it's not linear. Then you're going to apply the model onto the test set to check performance. And as you can see here, the model tries to fit the best line to separate between your legitimate and your fraudulent events. The end result is a model that can more accurately delineate legitimate from fraud. Using this model, you can then catch more fraud and reduce friction to legitimate customers or reduce the number of human reviews that you're doing. But when we spoke to customers about implementing machine learning for fraud detection, they had many challenges, and they weren't able oftentimes to create the top performing fraud detection models. So they weren't reaping the benefits of ML for fraud detection. Like for example, we heard from customers that top data scientists are costly and hard to find. They tried one size fits all models, but they tended to underperform. They didn't often have the supplemental data to create the high performing model. And then they might not have had the ML fraud detection expertise to complete the data transformations and feature engineering to really come up with the right set of data and features to train the model. And there's also with fraud the challenges around imbalance, where oftentimes your fraud rate's well less than 1%, and you're often looking to identify a needle in a haystack efficiently. For these reasons, we introduced Amazon Fraud Detector. So Amazon Fraud Detector is a service that makes it easy for businesses to use ML to detect online fraud in real time at scale. Fraud Detector is part of the AI services category among the AWS ML offerings. What this means is that it's a fully managed AI service where we've tried to automate much of the process of creating high-performing custom fraud detection models so customers can benefit from ML without worrying about the heavy lifting. Fraud Detector is designed to help companies detect common types of online fraud. For example, new account fraud, where bad actors are using fake or stolen identities to create accounts to use for committing fraud or abuse. You can use Fraud Detector to selectively introduce friction or verification steps on sign-up based on risk, as well as online payment fraud, where bad actors are using stolen credit cards to purchase goods and services online. With Fraud Detector, you can flag suspicious transactions, helping to reduce credit card chargebacks. Other use cases you can use Fraud Detector for include guest checkout fraud, where you have a minimal set of data to assess risk, or postpaid service abuse. This is common AWS's use case where customers use the service throughout the month and then they are billed for it at the end. In those types of business models, you have to get very good at detecting fraud right up front with limited information. Some of the key features of Fraud Detector include pre-built fraud detection model templates. You can think of these as end-to-end recipes that help you build a high-performing model to detect a particular type of fraud. We'll get more into those in a little bit. The automatic creation of customized fraud detection models for your business. Each of the models learns from past attempts to defraud Amazon. For fraud teams that are actively building fraud detection models today in SageMaker, you can bring those models into Fraud Detector and use them with custom fraud detector models or with fraud detector rules. And then finally, there's a console where we have an interface to review past events and detection logic to troubleshoot or audit how a particular decision was made. So how does it work? First of all, you take your training data set, you upload it to S3. Amazon Fraud Detector will pull your data set from S3, run it through our automated machine learning pipeline that we've built specifically for fraud detection models. We'll get more into that pipeline on the next slide. The output from that automated process is a customized machine learning model based on your data set and enriched data that we use through the automated model building process. You take your model at that point and you add it to a detector and you combine it with rules. You can think of a detector as a container that holds any models and rules you want to use to evaluate an event. Once you're happy with your detector logic, you can then publish that detector and use the fraud detector prediction API to send new events to get scored using your custom detection logic. Once you upload your training data and select your model template, you tell us a little about your data set and click a button to train a model. This is where Fraud Detector takes care of the heavy lifting using an automated fraud detection model building pipeline. In the first step, we validate that data. We check to see if your data contains the required inputs, whether there are enough records in the file, and the existence of enough fraud labels. Next, we enrich and transform that data. For example, we supplement your raw data with risk data from third parties, such as we'll take your IP address that you supply in your data set, for example, and enrich it with geolocation information. At this point, we also enrich your data with fraud patterns we've seen on AWS and Amazon. After step 2, we have all the data we need to train your model. Now, the automated pipeline transforms this data into the specific features designed by Amazon fraud prevention ML experts. These are the same ML research scientists that build and design the models that protect AWS and Amazon. We then train a series of models and select the best performing model. The pipeline then outputs a trained model customized to your business along with metrics to help you understand performance. If you're happy with the performance of that model, we have one-click deployment to make that model version available for real-time fraud detection using the customized fraud detection ML model API. The model template's a key concept in Fraud Detector. For example, we have the Online Fraud Insights model template. This model template helps build models that detect risky events based on events attributes. It's best for detecting potential fraud when historical account or user data is limited. It's inspired by models and techniques used to protect AWS account registration, but it can be applied to a number of different use cases, including new account signups, first transactions, guest checkouts, and others. Each model template has required inputs. For the Online Fraud Insights model, there are 3 required data elements, many optional data elements, and then customized inputs. The required data elements for this template, for example, would be an email address, an IP address, and an event timestamp. Optional elements would be things like billing address, shipping address, order details. We recognize these inputs, but you don't have to provide them in your training data set if you don't have them or don't want to. And then the third bucket, customized inputs. These are things that may be unique to your business that we don't necessarily recognize, but you feel that they might add signal or be predictive of fraud, and you want to include them in your data set when you train an online fraud insights model. Okay. So to generate fraud predictions using Amazon Fraud Detector, you'd first collect, for example, some checkout information about a purchase from a customer on your website. Your website would then call the Amazon Fraud Detector service with this information. The service would run it through your detector, including your model and any rules you set up, and return an outcome based on the rules you set up, as well as any raw scores from the models that you're using. Based on this response, your website can then adjust the customer experience accordingly. And with that, we'll go into a demo where I'll show you more about how to set up these models and create them in Fraud Detector. So before we go to the AWS console and the Fraud Detector service console, I'll show you a quick demo web application just to demonstrate the type of experience you can enable using Fraud Detector. So what I'm showing here is a demo web app for a made-up company. The sign-up flow uses an Amazon Fraud Detector ML model and rules to predict potential fraud risk and adjust the second step of the sign-up flow accordingly. First, we'll enter details for a low-risk sign-up, and the account will get created in a single step. Next, we'll enter details for high-risk sign-up, and instead of completing the registration, the user will be directed to an additional verification step. First, the low-risk sign-up. As you can see, this customer got through registration in one step successfully. In the bottom left here in the box, we're displaying the response from the fraud detector API. We can see that the ML score that was returned was 431 and the outcome was low risk pass. This is based on the model and the corresponding rules that we've set up in fraud detector. Now let's try a high risk signup. In this case, you'll see that this customer is asked to confirm their identity with an additional step via SMS. You'll see down in the bottom left that this time the fraud detector API returned a score of 548 and an outcome of high risk verify. So now to see how this works from a service configuration experience, we'll flip over to the Amazon Fraud Detector console. First, to get the fraud detector, you can search for fraud in the AWS console. Click on Amazon Fraud Detector. And we're going to go through a couple of steps. The first step will be to train a custom fraud detection model, and then we'll add that model to Detector and publish the detector. Before we dive in, I'm going to show an example training data set that we'll be using. This is a basic data set for the Online Fraud Insights model, where it includes an email address, an IP address, and a timestamp, and a fraud label. Each row here represents a historical event or record, such as a new account signup. Now let's build our model. Come in here, we'll give the model a name. Quick description. The next step, we'll choose the model template. We'll select Online Fraud Insights. Below here, we're giving some information about this model template and the required inputs. In the next container here, we need to specify our training data source. You can create an IAM role on the fly. Today I'll select an existing IAM role. And then we need a training data location from S3. We'll come over here to S3. We're going to use the synthetic min 20K V2 dataset. I'll copy that path, paste it here, and hit next. Now you'll see that the service pulls in the headers of our training data set, and we need to map them to the required and optional inputs for this template. You'll see that 3 of them are mapped automatically, and we have a 4th one, fraud status label, to map. We'll come down here. For is fraud, we'll select the fraud label. But before I do that, here's where I want to show the types of inputs that this particular model template can accept. As I mentioned earlier, there's the small set of required inputs. Then there's a long list here of recognized optional inputs. And then at the bottom, if you had something that you were collecting as part of, let's say, an account registration that was unique to your business that you thought would potentially improve the model performance, you could include them here as custom numerical, custom categorical, or custom freeform text. So we'll select fraud label. Now that we have the 4 required inputs mapped, we come down here to map your labeled data. So fraud detector already knows that your is fraud column contains your labels. Now we have to tell the service what values in that column represent fraud and which values represent legitimate events. So in our training data set, we're using the value of 1 for fraud and 0 for legit. The third and final step is to review your configuration and to kick off a model training. So you can see now that we have a new model, new account model demo, and we have V1 of this model in status training. Models can take some time to train, so we're going to switch over to a trained model to continue with the demo. See that this model, AFD model, has version 1.0 and is status ready to deploy, which means it's completed training successfully. Let's dig into this model. First, let's review its performance. Every time Fraud Detector trains a model, it outputs a set of metrics about that model. As you can see at the top here, there's a metric AUC, and it says 0.95 or 96. Sorry. This is the area under the curve metric. It's what we use as an overall performance metric for a model. 0.96 is considered very high in the context of fraud detection. We can also see the expected performance at a range of false positive rates. The table below here is sorted by false positive rate and lists the corresponding true positive rate, precision, and the model threshold score that you would use to write your threshold or business rule around this model. For example, on the 5th row down, you can see that by accepting a risk that 4% of legitimate events are incorrectly labeled as fraud, you can capture 82% of all fraudulent events with a precision of 69%. Many times in the context of fraud detection and fraud teams, precision kind of translates into a Q yield on manual investigations. So, for example, if you're queuing all high-risk account signups to be reviewed by a human for a final decision, and you created a threshold rule that said queue anything above 195, 69% of the events that you queued for a manual review would turn out to be fraudulent events. So let's say we like this performance and we want to use this version of the model for real-time fraud detection. We'll come up here and click Deploy Model Version. In about 5 minutes, this version of the model will be deployed and available to be added to a detector. Now let's talk about detectors for a moment. As I mentioned earlier, a detector, you can think of a detector as a container for any model or models and rules that you want to use as part of a single evaluation of an event. So we'll come into the new account fraud detector example. This is similar to the detector that powered our demo web app registration. So you'll see in rules, we have 2 rules, a low score pass rule and a high risk verify rule. These rules are looking at the new account fraud insight score and whether it's high or low, above or below 500. And that model is referenced here. So pretty simple. With Fraud Detector, you can build out much more complex rule sets They don't have to be evaluating the outcome of an ML model. They can be independent of ML models. There's a lot of flexibility in the system. But for this demo, let's create a new version of this detector and edit some of these rules. So we'll hit duplicate. Here we'll go through a multi-step wizard to help configure the new detector. Let's leave the description as is. In the next step, we could swap out the models that we're using. Here's where you could import a SageMaker model endpoint if you wanted to use a custom model from SageMaker, or you could add an additional model that you've trained in Fraud Detector. We're going to leave it as is for this demo. Next, we can adjust the rules for the detector. Let's go in here and tweak the threshold score for these rules. Right now it's at 500. We'll go in and edit. Let's change it down to 400. Save those changes. We'll go into the second rule, do the same. And let's also add a second outcome here. So in addition to returning high risk verify in the API response, when this rule matches, we also want a tag of, say, SMS, so that we know to take an additional action. On step 4 is where we prioritize the rules. Because this is a very simple rule set with 2 rules, it's not much, there's not much involved in prioritizing it. But when you get to a rule set that maybe has 50 or 100 rules, you might want them to be evaluated in a particular sequence, and that's where you, this is where you would adjust that sequence. Finally, we get a summary of our configuration, and we can create the detector. Now we can see we have a new version of this detector, version 2.0, and it's in draft status. So we can perform individual evaluations right from this console. This is particularly handy if you want to test your detection logic and just do get a quick sample of what the outcome would be for a particular input. So give this a go. Run test, and the API responds with outcome low risk pass and a model score of 399. Everything looks good. Let's publish the detector. Come up here to actions, hit publish. Publish this version. We now have an active version of this detector. Now any new events you send to the Fraud Detector API will be run against this version of the detector. And finally, the last thing I would like to demo today is once you've been sending events for evaluation, you can come into search past evaluations and you can get a history of everything that you've sent. If you want to drill down into a particular event to see what data was used as input, which models and rules were used to evaluate the event, the results from any of those evaluations, any raw scores from the models, you can come into the screen and do that, and then you can drill down further. For example, if we had a very complicated rule expression and you wanted to come in here and troubleshoot, you could see exactly how that particular rule expression for that event was executed. So that concludes the demo of the service. There's one more thing I want to mention before we wrap up, and that's that we have a number of sample notebooks on GitHub for Fraud Detector. These notebooks will help you try out the different APIs that are available, give you an overview of the APIs, as well as there's a notebook to help you profile your training data set to spot inconsistencies, look at the mix of fraud, not fraud, and help you generally prepare a data set that will lead to success with Fraud Detector. And that GitHub folder is AWS-fraud-detector-samples. At this point, I just want to say thank you for joining the overview of Amazon Fraud Detector. And now we're going to take questions.